Hello. This is number 6, and this is a pretty tricky problem. So, if you got stuck or got confused, that's okay. Excuse me. So let's go ahead and dive right in. So a small ice cube with a mass m slides on a horizontal frictionless surface to the right with velocity v0 towards a large inclined ramp of mass 5m, which is initially at rest. The ramp is movable and can slide without friction on the same surface. When the cube slides up the ramp, it reaches a maximum height h and then slides down the incline. Okay? Find the speed of the ramp when the cube is at the highest point. So, sorry about that. This is definitely one to think about, okay? But there's actually an important key thing. When the block is at the highest point here, that means that it is not moving relative to the ramp, okay? Which means we can treat this whole thing as just one big object. So you can set this up using momentum, but to me it's a great opportunity to use the velocity of the center of mass, okay? If it's one object, then the velocity of that one object is the velocity of the center of mass. So if we can just find this velocity of the center of mass, then we'll know the velocity of the ramp, because they're now moving as just one object, right? There's no motion relative to each other. Okay, so we just need to find the velocity of the center of mass at the beginning, and we know that can't change unless there's an external force, and there's no external force here because there's no friction acting on it. Okay, so we have the velocity of the center of mass, and we just need to do the velocity of the first one, which is v0 times the mass of the ice cube. So that's the initial velocity of the ice cube times the mass of the ice cube plus the initial velocity of the ramp times the mass of the ramp all over the total mass. So m's cancel, and you're just left with v0 divided by 6. Okay, so that would be part A. You could also set it up using momentum, and so for this you'd have m v0 equals, here we have both, so m plus 5m v. We're trying to solve for that v there. All of the m's are in every single term, so we're just left with v equals 6v. That turns into 1, so 1 plus 5 there, okay, or v0. So our velocity that we're looking for is just equal to v0 divided by 6. So that's how you'd set it up using momentum. But definitely the key here is knowing that treating it as one object, since the block is not moving relative to the inclined plane or the ramp. Okay, let's go ahead and look at part B. So it says, find the maximum height to which the cube rises. And so this is more of an energy question, okay? When you're thinking of going up and down ramps, that's generally what we associate as an energy question. So we're just going to do energy at the beginning is equal to energy at the end. Okay, so the only thing moving before the block starts sliding up the inclined plane is just that kinetic energy of the block. Now I'm going to have two types of energy at the end because both the block and the ramp are moving, so they will have kinetic energy. But then also the block gains potential energy, okay, because it's moved up, so it will be PE here, okay. So I will have 1/2 m v0 squared. That's my initial velocity, right? That's what I'm starting with at the very beginning. And then I'll have 1/2 m plus 5m, because that's everything. And our velocity, we just found that, is v0 divided by 6 squared plus our mgh. Now here, my m is just the mass of the block, not the whole mass, okay? So we can go ahead and simplify a little bit. So we'll have 1/2 m v0 squared equals 1/2 6m v0 squared. Now this 6 is going to cancel out with one of these 6's, so I just have something like that, right? Plus mgh. Now I can cancel the m out of everything. So I'll have 1/2 v0 squared equals 1/2 v0 squared divided by 6 plus gh. Okay. So I can go ahead and I'm going to multiply everything by 2. Okay, just to give it a little bit of a cleaner look, v0 squared equals v naught squared over 6 plus 2gh. Okay, and then I'll go ahead and subtract my v naught squared over 6. So I'll have 5 v naught squared over 6 equals 2gh. Remember, I'm solving for h. Then I will go ahead and divide. So I'll have h equals 5 v naught squared over 12h. Sorry, 12g. Okay, and so the really tricky thing here is realizing that you can set it up with energy. And the reason we can set it up with energy, even though it's sort of a momentum-ish type question, is because there is no energy loss to friction. Normally you have two objects bumping into each other. Some energy is going to turn into heat, but in this case there is no friction between the two things, so we can use energy here. Let's go ahead and look at C. Now C is definitely a tricky one. Okay, so C says find the final speed of the ramp when the cube returns back to the horizontal surface. Now, as I said earlier, we can use energy here. Okay, so we are going to set up an energy, EI equals EF. Okay, but let's go ahead and see what the problem is with just setting up energy. So I'll have my initial. So I'm going to go ahead and start at the point we kind of, well, no, we can go ahead and start at the very beginning. So we'll just do 1/2 m v naught squared, right? We know that the total energy is never going to change because we're not losing anything to friction. And so then this is going to equal the energy at the end. So we'll have 1/2 mv, and then I'm going to put a b for a block squared, plus 1/2 5m v ramp squared. Okay, so we have two things here. Now the problem is that I don't know what this is, and I also don't know what this is, right? And so I know all my other variables, but I don't know those two, which means that I can't actually solve this yet, right? I have one equation but two unknowns. So what do I need? I need another equation. So I got to figure out something else. Well, I also know that momentum is going to be conserved here, right? I have interaction of these two blocks, but momentum has to be conserved. So let's go ahead and set that up. So momentum at the very beginning is just going to be my, I'll go ahead and write this down. Sum of the momentum at the beginning is equal to sum of the momentum at the end. Okay, and so the momentum at the very beginning is just mv naught. Okay, and that's going to be equal to mv block plus 5mvr ramp. Okay, and so let's go ahead, and now we have two unknowns. Oops, I'm going to go ahead and undo that. Two unknowns, right? But also we have two equations, so we actually can solve this now. Okay, now I have two equations, two unknowns, but I'm looking for, at least in this question, I'm looking for the final speed of the ramp. Okay, so what I'm going to do is I'm first going to simplify a little bit. So I can go ahead and cancel out all of these m's. And I'm going to cancel out the 1/2 because that's also in everything. So I have v naught squared equals vb squared plus 5vr squared. And then on the other side, I can go ahead and cancel out all the m's. So I have v naught equals vb plus 5vr. Now what I'm going to do is I am going to solve for vb over here, okay? And then I'll end up plugging that in over here. So what I'm going to do is get rid of that velocity of the block, and then I can actually solve for the velocity of the ramp, okay? So I'll have v naught minus vb equals 5vr, okay? And then go ahead and divide by 5. So that will cancel that out. So now you'll notice I've made a mistake, right? So I just solved for the velocity of the ramp and not the velocity of the block, okay? So So I need to go back and actually solve for the velocity of the block. So just subtract that 5VR. Okay, so I have V naught minus 5VR equals VB. Okay, and now I can go ahead and plug that in. So I have V naught squared equals V naught minus 5VB all squared plus 5VR squared. Sorry, this is also a VR. Okay, the velocity of the ramp. So next, I need to actually multiply out. So this will just equal V naught squared minus 10 VR V naught plus 25 VR plus 5 VR, and this one's squared and this one's squared. Okay? Just multiplying out. Then I can go ahead and subtract V naught squared from both sides, so that's going to go away. So I'm just left with 0 equals negative 10 VR V naught plus 30 VR squared. Okay. Next, I'm just going to factor out my VR. Okay. So I'll factor out that, and then I have 30 VR minus 10 V naught equals 0. So this gives me two solutions. One is VR equals 0, which is sort of the initial condition, so that's not really what I'm looking for. And then the second solution will be 0 equals 30 VR minus 10 V naught. Now I just need to solve for VR. So I have 10 V naught equals 30 VR. So divide both sides by 30. And I'm left with VR equals 1/3 V naught. Okay? And so that right there is the answer. And obviously that takes a lot of work. And there's some tricky algebra. But it really comes down to setting up both an energy equation and a momentum equation. If you're able to do that and correctly get to sort of this, maybe this first step here and here, and then maybe get that part, that can be a lot of the points without really doing a whole lot else. So it's definitely really important that you're doing here. This could be a good one where you get to all this algebra, you say, okay, I know how to solve this, but I'll come back and solve it later. Okay? Now, we can go ahead and look at part D. Okay? So part D says find the final speed of the cube when it is on the horizontal surface. Okay? And so what this is really saying is go back and look at part C and solve this equation here, but this time I need to solve for the velocity of the block. Okay? So we have velocity of the block is equal to V naught minus 5 VR. Whoops. VR. Sorry about my dog barking every once in a while. She's very cute, but she can get a little restless at the end of the day. Okay, and we know that our velocity of this is just 1/3, so I have 5/3 V naught is that. So we can go ahead and factor out V naught, so I have 1 minus 5/3, and so that is just negative 2/3 V naught equals VB. Okay, and that would be my final answer for this question. So D is really hard or really easy depending on whether or not you got C, right? I would also say that if you were able to set up maybe just this momentum part, let's say you were able to figure out, okay, I could figure out this something here, right? I got this. And you weren't able to finish out C, D would be a good one where you could just say, take that equation and then substitute in some value for V. VR, the velocity of the ramp, so that you can get a point for D. The points for D will probably be in, using conservation of momentum and then plugging in from part C. So even if you're plugging in the wrong number, you're able to still get some of those points. Now, this is obviously a really tricky question, so the really thing to focus on here is making sure you're putting some pieces together, you're understanding, and you're improving. That's what's so important. It's not, don't worry about always being able to get every single part right? It's important to get what you can get some of those easy points, and remember, not every question is going to be the hardest question, right? Remember, if you have any questions, feel free to email me. Thanks.